What's Gucci, everybody? And today I want to talk about more of the basic types of the C language. So far, we've seen basic types of data representation that can be used in C, and there are a few more I want to show you. As we've seen, probably the most common thing I've used in the last four or five tutorials is the integer type, which can represent basically a non-decimal number. It can represent a negative number or it can represent a positive number. But what I haven't told you guys, kept it a big secret, is that there are other types of integers. There are other ways to represent non-decimal numbers, and there are also ways to represent decimal numbers, which I will get to in this tutorial. I also like to note that in the description I will have a link to a Dropbox file which will have, again, a little info and just a little repeat and a write-up of what I talked about today. So what I want to show you guys is that other than an int, there is a short type. And I'm going to make this equal 100. And short basically is another integer type, but can be used to store much smaller values than integers. So it takes up less bits and bytes. Now, if you remember, I've been talking about bits and bytes about the last tutorials. And if you don't know this, this should be common knowledge, but it's definitely always good to review. I know I forget stuff. There are 8 bits in a byte. And what I'm going to try to do here is, as I show you guys new data types, I'm going to try to show you how many sizes there are. Now, if you have C on your computer or you're running it on Linux, you can definitely follow along and see how your computer defines the size of these variables. Now, what I have here is I'm going to use printf to print out an integer, essentially. But what I'm going to do is I'm going to use this function called sizeof. And what sizeof does is it takes a parameter of anything, any data type, or as you can see, structures or array, which I'll show you later, and it returns the number of bits that parameter is taking up, or the number of bytes, I'm sorry. So the number of bytes. So if you wanted to figure out the number of bits, you would times whatever returned by 8, because remember, there are 8 bits in a byte. I don't know if there's any clever acronym to remember that, but definitely remember that. 8 bits in a byte, not the other way around. So we'll print out the number of bytes, not bits. If you want the number of bits, you'd want to times it by 8, but I'm not going to do that. So just to show you here, I'm going to type up a short. I'm going to print out a short, and as you can see here, it's only 2 bytes, which is 16 bits. So that means that it can only represent, since it's signed, it can only represent from about negative 32,000 to positive 32,000. And I forgot to put a negative on the first one there. And the exact dimensions, I believe, will be it can represent 2 to the 15th, 2 to the negative 2 to the 15th, 2 to the 15th minus 1. I guess I can write that down. Negative 2 to the 15th to 2 to the... And I do have a binary tutorial which does explain this. 2 to the 15th minus 1. Okay? And again, if I made it unsigned, it would be from 0. It would be from 0 to 2 to the 16th minus 1. And if you don't understand, basically what I'm doing is I'm bringing all the negative values and turning them into positive values, so I double the positive values I can use. And this is an estimate. Okay, and now the next, a bigger integer type than short is obviously integer. And I'll just make another one here. And let's see, let's change it up. Let's make it my age. I just turned 20 this month. And there's 20. And now let's see, I'm going to print out the size of j and see how many bytes that is. So it's 4 bytes. So that means it has 32 bits. And basically that will again mean that it can represent, since it's signed, it can represent 2 to the 16th. Yes, I believe so. 2 to the 6th. No. Guys, I am so stupid. It can represent 2 to the 31st minus 1, and then on the negative side, negative 2 to the 31st. Yes, that's what's up. So it can basically represent negative 2 billion to 2 billion. That's what it comes about to. It comes about to 2.1 billion. Now, something I also may want to note that I forgot to mention earlier is that if you're following along, probably not yet, but some of the later integer types may print out different values. And this may matter if you have a 32-bit computer or a 64-bit computer. It's very likely you'll have a 64-bit computer like me. But I'm just saying you may get a different value. You could even have a 16-bit computer, which is very unlikely. You probably have to be watching this from a poor country or a really, really old computer, which hopefully you're not watching YouTube videos with. You have something else to do with that, like throw it away. But anyway, yeah, so I just want to say that you may get different values, and that's because your computer defines what it can hold for these values, and that's so they may be different. But what I'm showing you is the general values that these types should encompass. Okay, and the next type we're going to have is long. Long, we'll call it P. Again, it's another integer type. We'll make it 999. And print out P and see what P gives us. So P is if you need more bytes than an int, usually. But as you can see here, it printed out 4, which is the same value that J gave us. So even though on my computer, long and int are defined to be about the same value, on some other computers, long can be defined to be about 2 to the 64th. So it could on your computer it could say it has 8 bytes, which is 64 bits, which means it has a value of about 2 to the 63rd. That's a negative. 2 to the 63rd minus 1. Sorry, I gotta look at my computer. And then 2 to the 31. 2 to the 31 minus 1. Okay, but as you can see, that is not. It depends on your computer. Let me write that note down. Depends on the computer. And yes, so as you can see here, you have short, int, and long. I also want to note quickly that you can combine these, so I can do int long let's do lol equals I never thought I'd put that as variable, equals 0, and I can print out lol, and this won't really change anything. I still get 4 bits. It won't make it longer or anything. I'll show you something later that will make it longer, but essentially you can combine them. It doesn't change anything, but if you ever see that, most people do leave the integer out. I could do the same thing with short. I could just add int. I can't do int, but I could do short int, long int. I can also change them, I believe, so I can do int long, and that won't change anything either. So if you ever see any of these stupid things, basically, if you see this, it means someone doesn't know how to follow conditions and doesn't know how to be cool and listen to everybody. But hopefully you rarely see that in your programming days. Okay, so now we've learned about short, long, and int. I want to talk about the precision types. Now, the precision types are, okay, so I've showed you integers forever, and gee whiz, AJ, how do you define a number where I need a decimal? What if I want to define pi? What if I want to do an area calculation in my C program? How do I do that? I can't do that with integers. I would have to do some insane manipulation to do that. Well, there's a much easier way. There are floating types, and one of them is float. So float I already have a variable named I. We will call this awesome, because it is awesome that we can finally define a non-integer value, and we can define it as 1.2. Ooh, and let's print out awesome. Oops, my clicker clicks sometimes. So we printed out awesome, and there we go. I'm going to do that. I'm going to run this. Takes forever, and still it's 4 bytes. Now, this may be defined differently on your computer. It could be up to 128 bits, which would be 16 bytes, and so you got to watch out for that. But basically, floats have a precision, according to the IEEE, which is the Institute of Electrical and Electronic Engineers. They defined the standards for float and double. which apparently my computer does not listen to. Maybe it's just Eclipse. I'm not sure on that, guys, but I'm trying to give you the best value I can do. But it has a precision of 6 digits, and what precision is, it means the decimals. So I can only, well, that's 6, right? 7. Let me see if I can print, if I print this out, it only, what it does. It gives me an error. And why does it give me an error? Expected that before the statement. Yes. 1.634. So as you can see, it was off on the last digit, right? It gave me a 6 when there should have been a 7. No, well, let's run it again. Yeah, so 1, it's the 1.23434. So this is 1.23434, but then it rounded up to 5. It then rounded up to 7 because it can only represent a precision of 6. So it can only represent to 6 decimal numbers, which for most calculations will be okay. But maybe if you're doing a space calculation where you need to be very precise, this would not work because you need pi to the first 100 digits or something like that. The next type is the double. And the double is basically like a float, except it can store even bigger values. So it can store, according to the triple E, about 2.2 times 10 to the negative 308 to 2.2 to 1.7, I'm sorry. I'm looking at this in a book, times 10, which maybe I got to tell you guys about, to the 308. So as you can see, that's a very, very big number. It's pretty huge. I don't know if you can even, I don't even know if there's enough like molecules in the universe to describe how big that number is. But anyway, so that's what a double is, and you see that, and it has more, it's according to the IEEE, it's supposed to be able to store more bits than a double. And let's see if that's true. So I'm going to print out the size of the double here, and it's 8, so it's 64 bits. So even though 64 bits would only give you about this, is according to this thing the same thing as a long, that is not supposed to be true as defined by the IEEE, and may be different on your computer. But I'm just showing you, but you need to be able to know that a double can represent a very big value, and that short usually represents very small values. But if you're usually just using a typical value, you can stick to int. If you're really concerned about saving memory, you can use shorts if you're just using very small values like 1s and 0s and such. And to conclude this video, I know it's been going on for a little while, I'm going to show you the last thing you can do. You can combine long and double, and we're going to call it fun because we love fun, and we're going to make it like 1,000,000. Doesn't really matter. I'm going to print out the size of fun, and you can see, did it print out there? It's 16 bytes, which is 16 times 8 bits, which is a lot. That's 128, I believe. I'm going to go with that. I'm going to check it on my calculator right now. Yep, it's 128, and that can represent a very huge value. And so if you want to, usually the long double is not defined by the IEEE, so it is actually different on every computer. So you may get a different value here, but it's most commonly either 80 bits, which would be 10 bytes, or it's 128 bits, which is 16 bytes. So yeah, guys, I hope you know what now a short is, an int is, a long is, a float, a double, and a long double is. Thank you and have a great day.